This is the lecture over the final exam for Math 107. These are the final exam problems, give or take a few. We start with a rational function. This is really a rational function of x. We put the y in there anyway. It's the same. Is 3x minus 6 over 2x squared plus 6x minus 80. And the questions are to find the vertical and the horizontal asymptotes. The vertical asymptote is the value of x. This is the difference. What is a horizontal asymptote? It's a value of y. Okay. The vertical asymptote is the value of x such that the denominator, this is really p of x, some polynomial over another polynomial, such that the denominator q of x is equal to 0. So you have to find the value or values of x for which that's true. So what do we have for q of x? It's 2x squared plus 6x minus 80 equals 0. How do you solve something like that? It's quadratic. You have three ways: complete the square, factor it, or use a quadratic formula. The 2 in here makes things a little bit tougher, but look, you can factor it out. So if I factor out the 2, I have x squared plus 3x minus 40 equals 0. The 2 can be divided, and if we divide both sides by 2, we get this. X squared plus 3x minus 40 equals 0. Well, 0 gets in there. Can this be factored? Yes, it can be factored. And once it's factored, you'll have two values of x. Those values are the vertical asymptotes of that function. Now to find the horizontal asymptote, you're looking for the long-term behavior. And the way you do that is you consider the degree of the polynomial in the numerator, and you compare it to the degree of the polynomial in the denominator. In the numerator, I have a polynomial of degree 1 because the highest exponent, which isn't written, is 1. Now I look in the denominator. This polynomial is of degree 2. Okay. So, since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. There's an extensive reference section with lots of formulas in it, but of course you're going to have to know how to use them. So we start off here with an equation that describes your orbit about the sun in some solar system. Okay. And then you have a comet approaching from the right on the following path. And you're going to need to graph those and show the possible points where this comet might hit your planet if they happen to be at that same spot at exactly the same time. So you have to figure out what kind of orbit this is. Well, this is the equation, standard equation for an ellipse. And if you look at the standard equation for ellipse, or if you know it, then it has this form: x minus h squared over a squared plus y minus k squared, whoops, I'm out of room here, squared over b squared equals 1. I'll put the 1 over here. Okay, fine. The h and the k are the center of the ellipse. In this case, the h and k are 0, 0. So it's an ellipse centered about the origin. The a squared appears down here. If this is a squared, then a is 10. The b squared is here, and the b is therefore 8. That means starting at 0, you go plus or minus 10 in a to get the major axis, and plus or minus 8 in b to get the minor axis, and then you connect those, and that will be your ellipse. Now we go down here and look at the equation for the comet. We see a similar situation, but we see the minus sign. When we have a difference in signs between the two terms, this is an equation for a hyperbola. Right? So again, we have x minus h squared over a squared minus y minus k squared over b squared equal to 1. In this case, h is 5, k is 0. So the center of this is x of 5, y of 0. Okay, the a squared appears here. That gives me an a of 3. The b squared appears here, so we have a b of 2. Alright, we'll need to do one more thing. We have to remember here, we're going to have to mark where the sun is. So if you remember, for an ellipse, there is a relationship between the a, b, and c being the distance to the focus from the center, and that's c squared equals a squared minus b squared. So I've got 10 minus 8, which gives me 2. So c is the square root of 2. Okay, so now I know this much, and now I can try to graph it. I've written the equations here so I can kind of half remember them. So this is the ellipse. Its center is at 0, 0. This is a squared term, so a is 10. This is the b squared term, so b is 8. Okay. I mean, starting at 0, I have to go over 10. Okay, to 10 here, that's going to be the outside edge of the ellipse. And here is the other end of the ellipse. So the ellipse is going to go through this point and this point. For the b, I use that as a vertical distance. Okay, here's the 8 up here, and I have to go down to minus 8. Okay, here's the negative 8. And I connect those, which if I had any kind of artistic talent, I could make an attempt to do that. I'm going to end up looking like a really bad something, I don't know, football kind of thing. Okay, that's very bad, but there's your ellipse, and this is the main thing, that you've got plus or minus 8 in y, plus or minus 10 in x, center at 0, 0. Okay, remember we computed c was going to be the square root of 2. So to find the focuses for this ellipse, I have to go square root of 2, which is 1.414, so it's about here. So here's one of the focuses, and here's the other focus. Okay, I said that the sun is at one of them, so I could, well, what kind of colors do I have here? Oh, okay, I got yellow. So I can put the sun here. Let's say that's my elliptical orbit about the sun, that's marked there in yellow, at one of the focuses of the ellipse. Now for the comet is coming in at the right. And the center of the comet, let's use a different color for the comet. The center of the comet is at 5 and 0. So that's 1, 2, 3, 4, 5. Here's the center right here. And now that's what we have to do with a hyperbola is draw the fundamental rectangle. So the A is 3, the B is 4. So from this point I go over 3, I'm drawing my fundamental rectangle, 1, 2, 3, it's right here, and I have to go up 4, up 2, what am I saying? 1, 2, and down 2. Okay, this being a little easier for me to draw, here's the fundamental rectangle coming in for this hyperbola. Alright, not done yet. I have to draw these diagonals. And get the diagonals to go out a way so you can, I see some people don't always have them all the way out. Okay, there's a fundamental rectangle. There are the asymptotes, which are those diagonals drawn in. Now I have to draw the hyperbola. In this case, it says a hyperbola, this path is coming in from the right. There are two branches. Let's draw those in different colors. What colors do we have here? Okay, how about that color? All right, so it would start right here at the edge of that fundamental rectangle, and it swoops out like this along those asymptotic diagonals. And that is the path of the comet coming in from the right. If the comet comes in from the left, you start over here, and you would draw this part. Okay, where can you get hit by this comet? Obviously, you could get hit right here, or right here, if your planet and the comet happen to be in either of those places at the same time. If you use this other branch, you could get hit here and here. Obviously, this comet might not make it do too well by the sun. You might have a problem here if it's coming in like this. Okay. Now we have the famous difference quotient. You will be given this formula. You don't have to memorize that formula until you get to calculus. And here you're given a function and you have to plug it in. So what does function evaluation say? It says anything that's in here I use to replace the x, and I have to do it in parentheses. Okay, I'm going to work this out. 2 times x squared plus 2xh plus h squared plus 3. And then work out all these terms. 2x squared, 4xh, 2h squared plus 3. Now when you go to assemble the difference quotient, this is going to go in the denominator. 2x squared plus 4xh plus 2h squared plus 3. And then I have to subtract from it this function. Be sure to subtract the entire function. Minus 2x squared minus 3, all divided by h. Now you see that certain things cancel off. Okay, and I'm left with, okay, gotta make some room. And I'm left with 4xh plus 2h squared over h. Now, please do not think you can just cancel the h's here and leave the h squared term. I hope by this time you know better than that. That is one of those unforgivable errors. It's on the list. This is really, as you know, two problems, or you can do factoring. Okay, now you can cancel because these are monomials over monomials, or at least factors over factors. So I can cancel the h's here, and in this case I just cancel one of them. And that is my answer, 4x plus 2h. That's the answer. It still has an h in it. Okay, here's sigma notation again, and I'm going to give no credit for brute force. I want the sum broken into smaller pieces and the constants factored out. Why is that I want that done? Because that's how it's done in computer science. To brute force go at this, and to make, for example, from 2 to 4, that's no big deal. But if you're going many iterations, you're adding up a whole bunch of numbers, you need to factor your constants out, so you only have one multiplication at the end. Right? So I don't really care that you come up with the answer. I care that you know this part of sigma notation. I want you to know how to handle sigma notation. So I can break this. I break it at the plus and minus signs. So this becomes the sum, n equals 2 to 4 of 2412 over n squared, minus another sum, n equals 2 to 4 of 0.12n. Now, constant terms can be factored out. This is multiplying everything, and it can come on the outside. This can also move to the outside. So you end up with 2412 times the sum from n equals 2 to 4 of 1 over n squared, minus 0.12 times the sum from n equals 2 to 4 of n. You can work this out, but you need parentheses. I'm going to have to go up here to make a little room. Alright, so moving up there, which give yourself enough room so you don't have to do this. Okay, so this equals 2412 in parentheses. Now evaluate it, but don't be sure you have the parentheses here. 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, and at that point you can leave it. You don't have to do any more work for the final. Minus 0.12 times 2 plus 3 plus 4. Again, I don't care about the answer. I care that you know that you can break a sigma notation at plus and minus signs, and that if the constant is multiplying everything, it can come to the outside and be a multiplier. Those two things I want you to know. The third thing is that when you evaluate something where you have this multiplier in front of a sigma, you must keep that sum in parentheses. So you don't just multiply the first term and not the others.